Human physiology hides an elegant hierarchy, a silent decision-making system that chooses what to burn, what to spare, and what to defend at all costs. And if you've ever wondered what your body fights to preserve for as long as possible during fasting, you're not alone. Researchers have pursued this question for more than 4 decades. It isn't just about energy, it's about survival strategy built into our biology since prehistoric times. And in this video, you'll discover an answer that may surprise you more than anything else you'll hear today. To understand this last thing the body gives up, we need to look beyond the surface idea that fasting is simply not eating. Inside you, a biochemical chess game starts the moment food stops arriving. Every molecule, every stored drop of energy suddenly becomes precious, and your body selects carefully what to sacrifice first. But here's the twist. It doesn't make these decisions randomly. It follows a pattern shaped by evolution, tested during long hunts, harsh winters, and scarce resources. Scientists studying prolonged fasting, from early research by George Cahill in the 1960s to modern metabolic studies, found that the body goes through predictable phases. Yet within these phases, one thing remains astonishingly protected, something your body will defend until it has no other choice. Something we will unravel piece by piece as the story unfolds. So stay with me, because the deeper we go into this metabolic labyrinth, the clearer the answer becomes. And by the end of this video, you'll understand not just what your body protects, but why evolution made it non-negotiable. Before we continue, comment yes or no. Did you already know that your body has a strict hierarchy of what it burns during fasting? Your body doesn't consider you fasted just because you skipped a meal. True fasting begins only after insulin levels drop significantly, allowing stored energy to be accessed. This shift usually happens several hours after your last food intake, and it marks the point where your internal systems switch from external fuel to internal reserves. Think of it as your metabolism flipping a hidden lever from fed mode to survival mode. During this transition, your cells undergo a quiet but profound chemical transformation. Glucose begins to decline, liver enzymes activate pathways that were dormant, and fat-burning mechanisms wake up. This isn't chaotic, it's beautifully orchestrated. And this orchestration is what determines what gets used first and what remains untouched as long as possible. Scientists often refer to this stage as the metabolic inflection point. Studies in the field of nutritional biochemistry show that this shift triggers autophagy, increases adrenaline slightly, and reprograms energy distribution throughout the body. Your body becomes conservative, strategic, and incredibly efficient, almost as if it remembers the scarcity of ancient times. As this biochemical shift unfolds, the body begins preparing to defend its most essential systems. And understanding that defense strategy is the key to discovering what it refuses to give up until the very end. A few hours into fasting, your metabolism is already rewriting its rulebook. Hormones like glucagon rise, instructing the liver to release stored glucose. Meanwhile, your sympathetic nervous system stays alert, ensuring that you remain mentally sharp, a trait evolution selected to help our ancestors locate food during periods of scarcity. This unique balance of calm and urgency is why early fasting feels surprisingly stable for most people. But even as the body appears calm from the outside, inside, dozens of energy pathways compete and negotiate. Every organ wants fuel, every cell wants stability, and yet the body cannot keep all systems running at full power. Instead, it starts to rank priorities with quiet precision. Systems vital to survival stay fully supported, while non-essential processes begin to slow down. This internal reorganization doesn't happen randomly. Scientific studies show clear metabolic phases in which the body cycles through stored glucose, mobilizes fat, protects muscle tissue, and maintains brain function. These shifts allow humans to survive days, even weeks without food in controlled environments. They also reveal what the body is trying desperately to avoid using as fuel. As this metabolic choreography unfolds, one truth becomes clear.
Your body is preparing to defend one specific resource above all others. And understanding this reveals the secret behind what it will absolutely not give up until the very end. The body follows a strict order when deciding what to burn during fasting. This hierarchy is not intuitive, but it is deeply scientific. It starts with glucose, then moves to glycogen, then to fat, and only much later does it consider breaking down significant amounts of muscle protein. Each step reflects millions of years of evolutionary pressure. Humans who managed fuel wisely survived. Those who didn't pass their genes. Researchers who study fasting metabolism often describe this hierarchy as a layered defense system. The first layers come off easily, like peeling soft skins from fruit, but as the layers become more precious, the body becomes more protective. Some tissues are considered too valuable to sacrifice early, especially those responsible for cognitive function and mobility. This hierarchy explains why early fasting feels manageable. You're only using expendable resources. As you move deeper into fasting, the body's strategies become more drastic but still controlled. Enzymes shift, hormones adjust, and the body leans heavily into fat oxidation to spare protein. This sparing effect is one of evolution's greatest gifts. And yet, even within this hierarchy, there is something the body defends more fiercely than muscle or fat, something it considers the final line it will absolutely not give up until the very end. Glycogen is the body's emergency savings account, fast, accessible, and limited. Stored mainly in the liver and muscles, it provides a quick burst of glucose whenever you need it. But during fasting, this reserve is used up quickly. Most people deplete their liver glycogen stores within roughly 1 day, sometimes even faster depending on activity levels. That's why glycogen is always the first soldier to fall in the metabolic battle. Once glycogen levels begin to drop, the body signals a strategic shift. It stops relying on rapid-fire glucose and moves towards slower, steadier sources of energy. This shift is crucial because it prevents sharp drops in blood sugar and maintains enough glucose for organs that absolutely require it, such as certain cells in the brain and red blood cells. This rapid depletion of glycogen is not a failure, it is a design. When glycogen empties, fat metabolism accelerates. Hormones like adrenaline and growth hormone rise slightly to preserve muscle tissue, while low insulin opens the door to fat-burning pathways. Glycogen stepping aside allows the rest of the energy hierarchy to activate fully. Understanding glycogen's role reveals something important. The body is willing to sacrifice short-term, high-energy reserves early on so that it can protect more vital resources later. And this brings us one step closer to understanding the very last thing the body gives up during fasting. When glycogen steps aside, fat becomes the primary fuel, not by accident, but by evolutionary design. Body fat is the most energy-dense storage system we possess, capable of sustaining humans for extended periods without food in controlled environments. Studies on fasting physiology consistently show that once the shift occurs, fat oxidation becomes the dominant engine powering your body. It is slow, efficient, and remarkably stable, making it the perfect long-term survival resource.
This silent army of stored triglycerides begins breaking down into fatty acids, which then travel to tissues capable of burning them. The liver, meanwhile, converts some of these fatty acids into ketone bodies, a crucial adaptation we will explore soon. This transition dramatically reduces the need for glucose, preserving it for organs that rely heavily on it. What makes fat such a powerful commander in this metabolic battle is that it allows the body to protect muscle mass for as long as possible. Protein is biologically expensive, woven into enzymes, tissues, and structures essential for life. To burn significant amounts of protein too early would be a costly mistake, one evolution avoided by relying on fat first. As fat takes control of the energy strategy, your body enters a stable state that can last for days under controlled conditions. And with this shift, we inch closer to the real mystery. If fat can sustain us for so long, what exactly is the body trying so hard not to give up? Many people believe that the body starts eating muscle early in fasting, but scientific research shows the opposite.
In the initial stages, the body protects muscle tissue as if it were a priceless resource. This muscle-sparing effect is driven by hormonal adjustments, including elevated growth hormone and reduced insulin, both of which help maintain lean mass, while fat becomes the main energy provider. Muscle is vital for movement, temperature regulation, and metabolic stability. Losing it early would reduce your ability to hunt, travel, or escape danger, all essential for survival in ancient environments. That's why evolution crafted a system where muscle breakdown remains minimal until fat stores begin to run critically low. It's true that a small amount of protein is used during fasting, but not primarily from muscle fibers. Instead, the body recycles amino acids from worn-out cellular components through autophagy, a brilliant mechanism that cleans, repairs, and fuels simultaneously. This process actually improves metabolic health and delays the need to break down functional muscle tissue. Understanding this protective strategy reveals a deeper truth. The body is willing to use some resources, even valuable ones, but only in ways that maintain overall survival. And it continues to guard something even more essential, something it refuses to sacrifice until the final stages of prolonged fasting. The brain, despite representing only a small fraction of body weight, consumes a disproportionately large share of energy, roughly 1/5 of all the calories you burn at rest. This constant demand explains why fasting triggers so many metabolic adjustments aimed at preserving brain function above all else. If the brain fails, nothing else matters for survival. During early fasting, the brain relies heavily on glucose, but this dependence would be unsustainable if the body continued using glucose at the same rate while no food is entering. So the body adapts. It begins shifting the brain toward ketone use, reducing its glucose requirement dramatically. This shift is not just efficient, it is life-saving. Ketones cross the blood-brain barrier easily and serve as a clean, stable fuel. Research shows that after several days of fasting, ketones can provide more than half of the brain's energy. This reduces the pressure on glucose reserves, which in turn reduces the need to break down protein into glucose through gluconeogenesis. This transformation is crucial because it buys the body time to survive without compromising brain power. And this adaptation explains why the body protects certain tissues until the end. They ensure the brain remains functional. But believe it or not, even the brain is not the last thing the body fights to preserve. Ketone bodies are not a backup plan, they are a masterpiece of evolutionary engineering. When fat breaks down, the liver converts some of the fatty acids into 3 types of ketones: beta-hydroxybutyrate, acetoacetate, and acetone. These molecules become the brain's alternative fuel, allowing humans to survive long periods without carbohydrate intake. This adaptation likely saved countless ancestors during times of famine.
What makes ketones remarkable is that they not only fuel the brain, but also reduce oxidative stress and improve mitochondrial efficiency. Scientific literature shows that ketones can protect neurons, regulate inflammation, and enhance energy production, benefits that ancient humans relied on without ever knowing the chemistry behind it. By shifting to ketones, the body drastically lowers its need for glucose. This means far less protein must be broken down to supply that glucose. The result is a metabolic system that defends muscle, safeguards organs, and prolongs survival far beyond what would be possible if glucose were the only fuel. Ketosis, therefore, is the body's way of delaying the moment when it must turn to its most precious resource, the one thing it absolutely does not want to give up. And understanding this sets the stage for the scientific truth revealed in the next subtitles. Protein breakdown increases only when fat stores begin to diminish significantly, a state that occurs after prolonged extreme fasting or starvation, not during controlled short-term fasting. This distinction, confirmed in clinical studies on long-term fasting, reveals that protein is not a primary energy source unless the body has no other choice.
When the body finally begins using more protein, it is a signal that survival is reaching a critical point. Muscles, enzymes, and even certain organ proteins can be broken down into amino acids to maintain blood glucose and fuel vital processes. But this is a last resort strategy, activated only when fat reserves no longer meet the body's needs. This shift is monitored by hormones like cortisol and by cellular nutrient sensors such as mTOR and AMPK. As fat stores shrink, the body becomes less able to support ketone production, forcing a gradual return to glucose-dependent metabolism and therefore to protein breakdown. But this moment occurs much later than most people imagine. Understanding this boundary helps us finally answer the central question. If muscle and fat can be used as fuel, even if reluctantly, then what is the very last thing the body sacrifices? The answer is approaching, and it reveals the core of human survival. After moving through all phases of fasting, from glycogen depletion to fat reliance, from ketone elevation to protein conservation, we arrive at the core of the question: what is the last thing the body sacrifices? The answer, revealed through decades of metabolic research, is essential structural protein found in vital organs, especially the heart. The body fights with everything it has to avoid touching these tissues because they are quite literally required to sustain life. Unlike fat or skeletal muscle, which can be reduced without immediate fatal consequence, the heart and key organ proteins are irreplaceable. The body protects these tissues through layered metabolic strategies. First, it maximizes fat use, then it shifts the brain to ketones, then it recycles damaged proteins instead of breaking down healthy ones. These steps exist for one singular purpose: to delay the moment when essential proteins might be threatened. Only when fat stores fall to extremely low levels, exposing the body to starvation rather than controlled fasting, does the body begin touching these precious reserves. The scientific literature is clear. In prolonged starvation studies, the body continues sparing heart muscle even when skeletal muscle loss becomes severe. This tells us that the metabolic hierarchy is not simply protein last, but rather vital organ protein last. These tissues form the absolute foundation of survival: the heartbeat, the diaphragm's movement, the liver's detoxification, and the kidney's filtration. Without them, even the most adaptive metabolic strategies fail. This is why understanding fasting requires nuance. Controlled fasting pushes you through metabolic adaptation, but the body's deepest protective instincts remain intact. Only in extreme, life-threatening deprivation does it begin sacrificing the parts of you that evolution has spent millions of years teaching your biology to defend.
Knowing what the body protects until the final stages of starvation transforms how we understand modern fasting practices. Controlled fasting, whether intermittent, alternate day, or extended under supervision, does not push the body into these extreme phases. Instead, it keeps you within the adaptive metabolic zone, where fat is burned efficiently and protein remains largely protected. This is why fasting can be sustainable and safe when done with knowledge and intention. Modern research highlights benefits such as improved insulin sensitivity, enhanced autophagy, reduction in systemic inflammation, and better metabolic flexibility, all effects that occur far before the body ever approaches the dangerous stage of essential protein breakdown. When fasting is stopped appropriately, the body transitions back seamlessly to normal feeding, rebuilding glycogen stores and restoring anabolic processes quickly. Understanding the hierarchy of what the body burns also eliminates common fears. Many people assume fasting instantly harms muscle or organs, but science shows the opposite. The body was engineered to preserve its most important tissues. This knowledge empowers you to fast with clarity instead of fear, recognizing that your biology is far more intelligent and protective than most people realize. And perhaps the most important implication is this: fasting must always be separated from starvation. Fasting is intentional, structured, and reversible. Starvation is not.
Knowing the difference is the key to harnessing the benefits without crossing dangerous boundaries, an understanding that honors both ancient survival strategies and modern scientific insights. If this video is helping you understand your body on a deeper scientific level, consider dropping a super thanks to support this work. It helps us bring more high-quality, evidence-based content like this to the channel. There comes a point where fasting ceases to be a metabolic advantage and becomes a physiological threat. This transition occurs when fat stores are nearly exhausted and protein breakdown escalates into the realm of essential tissue loss. At this stage, seen in historical starvation studies and clinical observations, the body can no longer protect vital organs, and survival depends entirely on how quickly nutrition is reintroduced. When fat is gone, ketone production drops sharply, and the brain is forced to rely more heavily on glucose again. But with no incoming food and no fat to convert, the only remaining source is protein from organs and skeletal muscle. This marks the beginning of the body's final descent, where essential tissues, including the heart and diaphragm, begin deteriorating. The body attempts to slow metabolism dramatically, lowering body temperature, heart rate, and energy expenditure in a last effort to survive. This phase underscores a crucial truth. The body was never designed to thrive without food indefinitely. It was designed to survive temporary scarcity, not permanent deprivation. The systems that protect fat, spare muscle, and fuel the brain with ketones are extraordinary, but they are ultimately finite. Once essential organ protein begins breaking down, the body enters a territory from which recovery becomes difficult and dangerous. And it is precisely this limit, the point where the body must sacrifice the very tissue it fights hardest to preserve, that defines the boundary between adaptive fasting and starvation. Understanding this boundary allows you to use fasting wisely, respecting both its power and its limits. If this video helped you understand how your body truly behaves during fasting, make sure to hit like, subscribe, and share it with someone who needs this science explained clearly. Your support helps this channel grow and reach more people who want real, evidence-based health content.